Hey guys, it's me. So today we're going to talk about protein structure. So I brought in some props for today. Okay. So when we think of a primary strand, okay, it is all the P's. Polypeptide chain with peptide bonds that makes a protein, primary. So you can think of it kind of just as like strings or beads in a pearl necklace here, okay? So these are all of the amino acids linked together with peptide bonds to make a peptide chain. So this would be your primary structure. Your secondary structure would be if you give this necklace to little Johnny and he decides to play. So he's messing around and he's making snakes on a table, right? He's wrapping around his finger. So these are the alpha helices, right? So you can see how things are going to start interacting. Or with the snakes on the table, right? The side arms and backbones and stuff are starting to interact. So that's your secondary structure. Okay, the tertiary structure is when you take this protein and you put it in your hand, okay, and you take it away from him because you don't want him to break it. So now, there's a saxophone, but now this is a single subunit protein, okay. This would be an example of like myoglobin, and you can see how everything is starting to interact. This is also when the hydrophobic effect is really going to be in play, because all of the carbons and hydrogens that are scared of the water, they're going to be hiding on the inside, hydrophobic effect, where the outside ones, those are going to be the hydrophilic that are polar. Remember, polar bears love water. So this would be polar on the outside, the hydrophobic effect would be on the inside. So this would be your tertiary structure. So when you see a keyword that says single subunit protein, this is going to be your key that it's going to be a tertiary structure. Okay, now your quaternary structure is when you're going to bring in multiple subunit proteins. So that's when all of these single subunit proteins start to interact with each other. So you see that they're going to be forming these bonds and just really acting all together as one. So a good example of this would be like hemoglobin, because that happens to have 4 subunits, right? So this is the multiple subunit protein would be the quaternary structure. So again, when you see single subunit protein, think tertiary and just, picture it. So think of like the hydrophobic effect when, the carbons and hydrogens that are scared of water, they're going to be hiding on the inside, okay? Where the hydrophilic, the things that love water, the polar bears, the oxygen, nitrogen, and sulfur, those guys are going to be on the outside, okay? And then the quaternary is going to be the multiple subunit proteins, okay? So hopefully that helps for you guys. All right, we'll talk to you later. My cat just hopped up. All right, we'll talk to you later. Bye-bye.